like I said, we're going to be covering some SolidWorks basics just to get everyone on the same page. So, you might be asking yourself, what is SolidWorks? SolidWorks is an industry standard CAD, computer-aided design tool, and it's basically a software that lets you make 3D objects in a pretty straightforward manner, a pretty accessible manner. The key to using SolidWorks and really any CAD is just making sure that any kind of part that you do design is designed in such a way that if you have to make changes and iterations, which anything is going to need iterative design, it isn't going to be a big mess trying to fix everything down the line. So yeah.
Yeah, so what are those steps that Brian's talking about? SolidWorks is very consistent in terms of how it's actually outlined. There's two main things that you're going to hear a lot. There's sketches and there's features. So sketches is essentially drawing something on a 2D plane. Think of it like a blueprint. There's only 2 dimensions here, but it includes all of your important dimensions. So like here you can see a circle traced out and it has a diameter of 1, whatever unit you're using. So with sketches, you plan everything out and then you use things that are called features to drag them out into 3D geometry. So there's a bunch of different features that we're going to go over. They're designed for different use cases and you'll make your sketches to fit those. But basically SolidWorks is like foundationally draw a sketch and then drag that into 3D into using a different feature. So that's the base case. You're going to be understanding what sketches are first.
Like I said, you're trying to make sure that as you go, you're able to make changes as required. And so there's a bunch of different ways that we specify dimensions. And so SolidWorks is a dimension-driven software in that it doesn't know what you want. You have to tell it, what you are trying to make, right? First of all, and the most important thing is you always need to be in the right units. If you're just typing in numbers, SolidWorks automatically will assume that you're talking inches. And if you're working millimeters, if you're talking centimeters, so on and so forth, that'll be a big issue. I'm pretty sure one of NASA's Mars missions failed because of a unit conversion error. So don't do that. Bad. First things first is there's relations, and these can be very powerful in terms of very quickly and very simply dimensioning a bunch of different parts, or not parts, sketch elements. So you can say that 2 lines are the same length. You can say that they're coplanar or parallel or perpendicular. You can say that they're vertical relative to the plane that you're in, or horizontal relative to the plane that you're sketching on. There's a lot of different relations that we'll talk about more in depth in a moment, but they're excellent until you forget what you've used. So not forget what you use. They can trip you up if you try to use them too much. And I feel like this is something that you'll learn with experience, where if you set relations like a daisy chain of equal relations, for example. But anyway, then you can use construction geometry. So, for example, a line that ends up not influencing the final shape. So you can use it to specify a midpoint between 2 other lines, so on and so forth. We'll also talk about that more. And then finally, you can specify like actual dimensions. So this line is 10 inches long. And you can actually use a variable that you can specify for the entire sheet, and that will let you change it with just 2 clicks instead of having to go into each and every sketch and make a modification. Yeah, and you can also use the dimensioning prompt to actually do calculations. You can say, this plus this divided by 2 and find the average without actually having to pull out an actual calculator. But yeah, you definitely want to start with relations and use construction geometry in order to come up with more constraints, and then finally use dimensions to get to that last level of specificity.
Yeah, so all that stuff that Brian just talked about all happens in a sketch, and you need to make a sketch first. And as Ryan said, sketches are two-dimensional drawings essentially, and you can only make a two-dimensional drawing on a two-dimensional surface. So you can essentially make a sketch on anything flat. So that might be a plane, like the front plane, the top plane, or the right plane, sort of as defined in the document. You can see those in this picture here down on the feature tree on the left. Or that might be an existing surface from something you've made. So say you created a box, you could make a sketch on the top of the box. Or if you made a plane, say you defined a plane as being, parallel to the front plane and 10 millimeters away from it, then you could make a sketch on that plane too. So to go about making a sketch, you can either go to the sketch tab along the top of your window and then click sketch, or you can just right-click the surface you want to create the sketch on. So you can right-click anything flat, and there's a little button to make a sketch on it. So that's handy. So I think that's it for this.
All right, and there are some sketch entities that you can incorporate into your drawing. This is just kind of a zoom in image of the toolbar that you just saw on the last slide. And you can make lines, circles, rectangles, arcs, a polygon, so a multi-sided shape. And points are also surprisingly useful. So you can access all of these in that toolbar by physically clicking on them, or you'll find later on it is a lot faster if you assign hotkeys, I think you call them, to each of the sketch entities. So common ones are like the keyboard letter L for line, R for rectangle, C for circle. And as you get faster and faster at CAD, you'll find that even something as small as finding an icon takes a couple seconds, and that time starts to add up. So having a system that you can access all of these sketch entities quickly ends up being very useful down the line.
So, tricky sketch entities, right? We talked a lot about sort of basic sketch entities. There's a couple things to watch out for. SolidWorks lets you do some things that can be helpful occasionally, but a lot of times just make things break later on down the line. So some of those sort of tricky things are sketch fillets, sketch mirrors, and sketch patterns. So a lot of times you want a fillet. First of all, a fillet is when you round a corner, and that's good for manufacturing things and also not having sharp edges on your parts. But mirrors and patterns are both ways to duplicate features within your part, right? So maybe you want a pattern of holes all the way around. Instead of drawing a bunch of circles, you're going to draw one circle and then pattern it. And you can pattern that within the sketch, but it's generally better practice to make your part and make the hole and then pattern the actual hole itself, just because that makes things break less later on down the line. And when things break less, you're a happier person. That's pretty much it there.
All right, so going back to my whole spiel about relations, you can, the only one that you really want to stay away from is fix, just because anytime you fix a point or a line or anything, the whole entity must remain exactly as it is. Or I should say, if you fix a line, it cannot move perpendicular. And if you fix the endpoints of a line, they are fixed in space. If you fixed a line itself, you could extend the endpoints in and out, but that's it. The fixed relation is a bit finicky and can lead to other dimensional issues. And generally, I would not recommend using it. But equal, concentric, tangent, all of these are very valuable. And instead of trying to use a dimension to specify the ways things are connected, it is just much, much faster. So yeah.
All right, so the next one we're going to talk about is construction geometry. Sometimes you want to create a line that you don't want SolidWorks to explicitly treat like a boundary, and you just want it as a reference. So sometimes we'll say you have a circle or something, and you want to draw a line through its center, and you want to be able to like cut the circle in half, but you want to just be able to reference that circle point like without actually treating it like a solid line. You create these things called construction geometry. So when you go to actually create a line in the tools that we mentioned earlier, there's a little drop-down box next to your line, and that allows you to choose between line and center line. So the center line tool basically creates this thing that we call construction geometry, which is just a dotted line, like you can see in this picture here. So you see those two circles and there's dotted lines going about the top left and top right corner. SolidWorks basically treats those just as visual cues for you and for dimension cues. So it won't treat those like a solid boundary, but you can reference those. So you could say, I want to create a circle that's 5 inches from this dotted line here. That's what it's useful for. But when you go to create a feature, like we were talking about earlier, SolidWorks will pretend like it doesn't exist. It's not a real solid line. So that's what they're really useful for.
And so all that stuff is very useful for dimensioning, references and things like that. You want people to know how big things are. Also, you want to know how big things are. And dimensioning is really powerful because you can basically draw a circle or make a circle and then tell SolidWorks, dimension it, tell SolidWorks how big you want it to be, and then SolidWorks will reset itself all around it so that everything's in reference to that one reference that you put in. So if I just make a random circle in space and make it 20 like that one, SolidWorks will configure itself so that that circle is 20 and everything else you do is based off of that. Now again, inches, millimeters, centimeters, you should worry about all those. But you always want to tell people, especially if you're machining something or you're running it by somebody else, the length of your stuff, your angles, and your diameter and your radius, because those are all very important for machining. Again, if you ever look at like a process sheet or a drawing design of a real thing, especially on co-op or something, if everything isn't dimensioned, it's not very good, and it should be, because every single thing has to be either referenced or you have to tell somebody how to build it. So you only need one dimension, which is nice, and you want to make sure your stuff is fully defined. And SolidWorks will tell you whether or not it's fully defined, and sometimes dimensions clash with each other. We don't want that. We want everything to be fully defined.
We're going to split up into breakout rooms, and this time just set the two sides of the center rectangle to equal, and then dimension one side to 10 millimeters.
Yeah, so we made a sketch. It's just this two-dimensional thing. It's not really good for much. You could have done it with a piece of paper, and a pencil. But now you can take it and use it to define a three-dimensional object. So some different things you could do with it would be to extrude boss base it. That's the name of one of the tools that essentially takes it and extrudes it outward into 3D space. So if you applied that to your rectangle, it would turn it into like a block. Well, I guess our rectangle's a square, so it would be a cube. And extruded cut, that would essentially perform the same action where it sort of takes this this two-dimensional square and projects it out into 3D space. But instead of creating matter, it would eat through anything it intersected. So if you had made other stuff previously, other 3D stuff previously, then it would chop through all that. Revolved boss base, that essentially takes a sketch and spins it around an axis of your choosing. So you could choose one of the sides of this, like one of the edges of your square, and spin the square around that edge, and you'd end up with a cylinder. So that would be cool. You could also do some of these other things. So patterns and mirrors. Once you get your cube, you could mirror the cube across across one of its faces, and you'd end up with I guess a parallel pipette or whatever, you know, a three-dimensional rectangular solid thingy. And then you can also make reference geometry. So say if you want a new plane to be, 2 millimeters offset from one of the faces of your cube, you could do that with the reference geometry tools. You could also make an axis that runs straight through the center of your cube, parallel to one of the edges or something like that. Then you can also do stuff to your block sort of after all this is done, or do stuff to your cylinder after all this is done, like filleting the edges. So that means just sort of rounding off the edges. So yeah, that's some, I know that's a lot of stuff, but it's essentially, once you've got your sketch, you can do a whole lot of stuff with it. And you can do that stuff by going to the feature tab in the toolbar and just clicking on stuff and messing with it. So you should go and mess with all that stuff, because it's fun, and that's how you'll learn. I think that's it for this slide.
Yeah, the extrude boss base feature is a very handy feature in SolidWorks. You'll find that most of the parts that you model in SolidWorks will start with an extrude. It'll either be an extrude or a revolve, so you're kind of doing one or the other. And I'd say probably like 70 or 80% of the features that you do will be extrude boss or extrude cut. So a very useful tool to know and know how to use wisely. So the example that you kind of see on the screen is a rectangular shape that has a hole in it. So the 2.5 millimeter, I guess, diameter hole is included within the bounds of the 10 millimeter side square. And then when you extrude that, it extrudes the material between those two shapes. So it excludes the circular portion. And this is helpful because you could have made this part by first extruding the square block and then making an extrude cut for the circle. But it is better if you can reduce the number of features and the kind of like length of the feature tree in SolidWorks if you can, just because when you start making more complex parts, it can clutter up the screen and make the design kind of less clear when you go back and try to edit features. So as much as you can accomplish in an extrude boss base is ideal, I would say.
All right, so now that we've got an extruded bit, the next sort of reverse of that, sorry, street noise, sort of reverse of that is the extrude cut, which is pretty much exactly what it sounds like. just like you can draw a shape and then extrude it out to make material, you can draw a shape and then extrude the material away. So in this lovely example, you've got your extruded square or cube, I guess, and then you can make your hole through the middle of it there. Pretty much it.
All right, and then in anytime you're going to extrude boss space or extrude cut, you'll have end conditions. So the first and most simple is just a blind end condition. So you're starting from whatever point and you're going whatever distance you specify. Doesn't matter what it intersects with. It's just going to extrude or cut anything and everything up to the point that you say. So, you know, it could be 10 millimeters. It could be 53.26 millimeters. Like, could be anything. Then you can just tell SolidWorks, okay, extrude cut all the way through anything and everything in that, you know, the projected direction. So it won't stop at a plane or a feature. It'll just keep on going until it's cut through everything. The midplane will say, okay, the sketch is on this plane, and similar to the blind, it'll go a certain distance, but the middle of the extrude or the cut will be on the plane that you're working on. This one's a little bit more niche, but still very useful to know instead of having to extrude twice or in two different directions. Can save you some clicks. You can also say, okay, extrude or cut up to a certain surface. And this is actually a very, very useful feature. I've used it a number of times in some of my parts. It's just really great for saying, okay, I want to cut up to here, and I want to preserve this feature as is. But say there's some material in between, we wanted to get rid of it, and it's super easy and straightforward. So yeah, next breakout section will just be extruding the square into a 10 millimeter cube, and then extrude cut a circle, and just try all these different end conditions and see how it works out.
Awesome. So Andy talked a bit about this earlier, but the Revolve tool is definitely one that kind of blew my mind when I was first learning SolidWorks. It's not initially intuitive, but it's so incredibly powerful that it's something you want to start getting your head around. It basically allows you to create really complex geometry from just a single feature, so it's super useful. So we have a demonstration right here on these two pictures. On the left, you can see the sketch that you have available. It's really simple. It's just an L shape. But then if you use the Revolve tool, you tell it to basically drag this outline right here about the small far left point. Brian, you want to highlight that? Yeah. So that's your axis right there by the 0.25 inches. Basically imagine drawing an axis right at that vertical point at the far left part of the L, and then dragging this shape around that axis. You'd create the bowl that you see on the right. So it's weird the first time you see it, but this is one of the most powerful like base features in SolidWorks. So it's something you want to definitely mess with and get practice with. Yeah, that's the outline of it. Brian's showing you kind of dragging it around. That's the idea.
Just to get a better perspective, actually doing it, just make a rectangle and revolve it and make a hockey puck. And if you want, you can do a T-shape or something more complicated if you'd like. So
just mess with it. Yeah.
Yeah.
So if you're gonna do something like a circular pattern or a mirror, exactly what they sound like, exactly what this picture is showing. So if you do something once, you don't want to do it again, then you can hit mirror or again hit circular patterning. And instead of doing it 4 times, you can do it once. For example, this one, when you do circular patterning, you have to pick like how often you want it. So for this one, it's every 90 degrees you want it, and you can select that again. You can make it with 6, you can make it with 8, however many you want. And again, this is just saving time. If you're making a colander, I don't know why you would be making a colander, but there are a lot of holes in that. You really don't want to do that every time, and you really don't want to take the chance of messing up because everybody does it. So this is not only like makes things quicker, but it also increases the quality.
So yeah, reference geometry. Reference geometry, it's kind of like construction geometry in sketches. So sketches, you know, you can draw those dotted lines to help specify where things are. Kind of like if you're doing a geometry proof or something, you know, and you want to make extra lines to make your proof easier or something like that. It works the same way there. But you can also do that in 3D with reference geometry. So probably the three most common types of reference geometry are planes, axes, and points. So the point of them is just to make it so that you have something to click on when you need to go tell SolidWorks where to make something. So say if you've got a symmetric part where everything's sort of symmetric about a center axis, maybe you want to make that axis be sort of this everlasting thing. And if you made it in a sketch, it would exist inside that sketch, and that would be okay. And I mean, you could still use it pretty much for everything that you could use a reference geometry axis for, but it's kind of better if you use a reference geometry axis and just put it where you want it, and then it'll be there for ever afterwards when you need to go tell SolidWorks to make things around that. And then planes, as I've mentioned before, just define I mean, that's common sense, right? A plane's a plane. But there are different ways to define a plane. So say in this picture right here, you've got a plane that goes, never mind, that's the front plane. But pretend that's not the front plane. Pretend that's a plane you made. You could say that plane is defined by going through the center axes of two of those cylindrical cutouts, right? So maybe you'd want to do that, so then you could you know, make some features based on those cutouts. So then if you change the positioning of those cutouts, then the plane will change too, right? So that's a big thing with this reference geometry. If you make reference geometry referenced off of other geometry, then when you change the original geometry, the reference geometry will change too, just as, you know, any other feature in SolidWorks will. That's the beauty of SolidWorks. And then points, you know, you can just click on a thing and make a point there, and there'll be a point there, and you can use that for stuff.
Just to practice the patterning, we're gonna again go back to breakout rooms and just give that a shot.
So fillets and chamfers, they are features that have a very important function in the real world. If you're doing any sort of subtractive machining with metal parts, they act to protect people's hands from being cut, essentially. And they also reduce stress concentrations that could build up if you have a hard edge. So you can see on this part, there are a couple fillets and chamfers, and in the scope of SolidWorks, you'll find that using fillets or chamfers is usually done at the very end. So it'll be kind of your last one or two features after you've extruded and made extrude cuts everywhere else.
All right, so next up is the hole wizard. And so the hole wizard is basically just a thing to make holes, right? Exactly what it sounds like. So we talked about extrude cuts earlier, and that's a way you can make a hole. You can sketch a circle and say you want it to be this diameter and then extrude cut it. But a lot of times when you're making holes, you're making them to be to put a screw in, right? Because a lot of things have to be attached together with screws. So the hole wizard just has all of the dimensions that you need for various screws and clearances and everything in it already. So instead of having to look up, you know, all right, what's the diameter of my screw and how much space do I need around it and all that jazz, you can sketch a point instead of a circle and then use the hole wizard to select that point and then tell it exactly what you need. So you can, in this example, you're telling it that you want a clearance hole around an M3 screw, and then it's going to know, because it already knows what dimension that should be, and it just makes it easier for you to not have to look things up all the time. So took a little bit of getting used to for me personally, but very handy. Would recommend.
I still mess it up. Takes like 5 minutes to get it all straight. And then once you have your part, you'll probably be making more than just one part. And a lot of times you'll want to see how these parts come together and how they interact with each other. And that's where assemblies come into play. And so just as we showed on the one of the early slides, how when we were getting started with our sketches, you needed to select create a new part. In this case, you'd create a new assembly and insert your individual parts, and they are all in relation to each other. So one will be fixed in space, and everything else will be related spatially to that fixed part. And typically it's not a good thing to fix more than one part because that can cause issues, just like the sketch relation of fixing a point or a line or any other feature. So yeah.
Sorry. So the way that you relate those parts is through mates. Actually, Brian, since this is the last slide, do you mind just stop sharing and I'll share an assembly that I have just really quickly?
Sure, sounds good.
All right, cool. I'm just gonna share screens real quick. So is this working all right, folks? Yep. All right, cool. So here's a basic thing. You have two parts here. This one, like Brian was saying, is fixed by its origin point. So this one cannot move, even if I want to drag it around. This guy is free to float. So once I have one fixed and one free to float, I need to tell SolidWorks how I want these two to interact spatially. So this is basically a link to a chain, and then we have pins here to keep the chain links together. So first thing I want to do is go to my mates, and then we have all these options available to us as mates. So in this instance, I know that I want this to fit in this hole right here. So to do that, I'm going to use the concentric mate, which basically tells SolidWorks, I'm going to tell you two circles, and I want them to basically have their center point be the same point. So I want them to have radius about the same point. So I'm going to take this circle here, and take this circle here, and then SolidWorks puts them together. I say, yes, that's what I want. And bam, SolidWorks knows that I want these holes to fit into each other. However, it doesn't know where it should be in this dimension. So it's important to keep in mind that you give it enough mates so that SolidWorks doesn't have any question about where you want the pin, and so that it can move around, unless it's a part that you want to move, but that's a different story. So in this case, I don't want my pin sliding out of my chain. So I want this guy to be flush with this piece right here. So to do that, I'm going to use another mate. I'm going to use the coincident mate. So I'm going to take the outermost circle here, and I'm going to take the outermost circle here, and it's coincident means right up against each other. So I want these two parts, or these two dimensions right up against each other. So I do that. Yep, that's exactly what I wanted. And now SolidWorks knows what my mates are. So this guy can't move at all. And with that, SolidWorks has enough information to basically represent this accurately. And you can keep doing this for more and more parts and incorporate them into a big structure.
Sweet, thanks Ryan. And I'm going to stop the recording there so we can take questions.